All right. So thank you for joining today's session. So because it's next to lunchtime, so I won't leave time for the questions. If you have a question, I will see some corner for discussion. So I'm Wei Huang. I work in IBM as a software engineer. So today I will share the lessons I learned in KEP and implemented in the 1.16. So before starting, I just want everyone on the same page to know what KEP is. KEP is short for Kubernetes Enhancement Proposal. It's a methodology or process we are right now following to make sure we have a consistent feature lifecycle management. It's not only a design proposal, but as well as some additional metadata adding to the KEP. So that it solves different personas like release team, like the developer contributors, as well as some external users. So just make sure everyone is on the same page about how the feature is and what's the roadmap. And here's a link about to store all the KEPs as well as some default template for you to start with. And before starting, what we are talking about today is at the point that you already have a thoroughly discussed the KEP. So that means as a contact of the KEP, you know almost everything about KEP, the scenarios, whether the KEP is applicable for, and what's the limitation, what's the motivation, and as well, you should be able to answer any questions about the KEP and all the scenario behind this. So by this point, the KEP should be already marked as implementable in the KEP YAML. And to start implementing this, you have to negotiate with the SIG leaders to say, okay, I want to get it implemented in the next release, for example, 1.18, and be sure to reserve your bandwidth because Kubernetes is using a 3-month release cycle for its release. So if you want to get it implemented in the 1.18, for example, then you have to get the code and test the review prepared and ready at least before the second month of the release cycle, because second month is usually the code freeze, end of the second month. And the next, get started, so you need to define the KEP scope and the breakdown and prioritize the items. First of all, ask yourself some questions. Usually a KEP, a feature comes with a new API, but sometimes it doesn't. So ask yourself whether a new API is needed. If it's needed, what kind of API you want? If it's upstream API or you can implement it as a CRD out of the tree. I will mention it a bit later on what kind of API you need. And also, in which component this feature belongs to. Sometimes the answer is obvious. For example, it belongs to API server, belongs to controller manager, but sometimes it's not. For example, the taint-based eviction, it was originally supposed as a feature in scheduling, but later on, brainstorm, the feature involves, it turns out that it's better to implement in the controller manager, specifically in the node lifecycle manager. So that is how the things. So think about it, in which components you want to get implemented. And this phase is a good point to continue about some discussion of the details of the KEP implementation. So make sure if you made some last-minute API change, make sure they are reviewed and the KEP is updated necessary. So by this phase, the output is, I usually put umbrella issues to organize all the items I need to implement and make sure everyone knows my plan. So here is an example. So this is for the EvenPodsSpread feature. So at the beginning of the implementation, I list all the work items one by one. So you can see here there are 7 or 8 items I need to finish in one release cycle. So also the reviewers knows, API reviewers knows, the SIG leaders knows that. Yeah. So let's talk about API, because API is so important as a bridge to coordinate different components to work together to make sure to achieve the event goal. So the first pattern I want to say is called indirectly reference pattern. So if you want to implement a feature, you can get API design in its own API group. For example, when we introduce the preemption feature in scheduler, we introduce a concept called priority class. So it's a standalone API. You can use KEP control to create that. You can also position standalone in etcd. And in pod spec, we introduced the field which of type string named priority class, so that from the pod, if you define a priority class, then it is able to fetch the priority class object. So I made it a dotted line, means it's indirect reference because it's using a string rather than just stored in place into the PodSpec API. Of course, we have indirect reference. Of course, we have direct reference. An example here is toleration. So, pod has the toleration to be able to tolerate the taints applied on the nodes. So but toleration is cannot live without associated with the PodSpec. That means you cannot use KEP control to create a toleration. That is not the case. So in this case, all the APIs sit together into the same package. And as well as when I implement the EvenPodsSpread feature, I added the topology spread constraints also using this pattern. So this is the second pattern. And third pattern is that we can implement it using a CRD. Like, for example, the volume snapshot in the SIG storage group is implemented as the CRD. And it has a way to connect back to the core API. In this case, the connection is called the PVC name. It also uses a string to connect with the core API. And some interesting here is that usually, sometimes, and I think Russ mentioned in the last session, sometimes an API comes in alpha feature using a CRD, but later it can transfer to the first pattern, which is the indirect pattern. For example, I mentioned runtime class here. And if you know runtime class in the alpha phase, it's a CRD. And in the beta phase, it transfers to the core API. Okay, this is third pattern. The fourth pattern is called component config. So component config right now serves as a unified API interface for the external users to specify some customized options for the Kubernetes component to run. For example, scheduler, controller manager, and API server. So in some cases, if this API is for the external user, and the external user has the flexibility to change that instead of defaulting them, so you'd better put them into the component config API. For example, we have a new feature called scheduler framework, which we want to enable the users to implement their own plugins along with the default scheduling plugins. So in this case, we put them into the API, into the component config. And also, I will also use the scheduling framework as an example. So external thing is one thing. So user can specify and implement their plugins, then also use the API object so that they don't need to vendor the upstream Kubernetes/Kubernetes. And internally, for the framework to work, we have some internal fields, internal algorithm, a handler to make sure those plugins are plugged in properly as a whole so that they can work properly. So for this kind of API, they don't need to be consumed externally, also doesn't need to persistent into a etcd or somewhere. So for this kind of API, they just are plain APIs, I would say. So in this case, just put them into the internal whatever package you want, and usually it doesn't need to involve a lot of code gens like client code gens, informal code gens, because there's no external user using them. It's just internal usage. So here's the API patterns I want to introduce. Because only knowing about this kind of patterns, you can put your KEP implementation, API implementation to the proper category. Sometimes it's a combination of different categories, but you better know what we have right now. So output of this phase is that you have API PR, you have new specs comes in, you have new GVK defined, and you have the code generated, and also have validation, defaulting, conversion, etc. So here is a code snippet I used in 1.16 to make sure this works. I will give you a shot. So this is the API PR looks like. So usually you have to make some manual API changes on both the internal and external types.go, and also use the CodeGen utility to generate the code files. The last one is, I think it's the latest added to make it compatible. Okay, this is API phase. And next, we can start implementing the component-specific code logic. So usually, if you're new to a KEP or to a component, usually the first thing is to learn from existing code. Usually the case is that the similar feature has existed before. So learn from others, what's the convention there, what's the flow looks like, just learn from existing code. And the other point I want to mention is that usually a feature comes in, usually brings in some inevitable overhead to current running paths. But the bottom line is that the users are not using the new feature should not be punished, especially when he even doesn't enable the feature gate. So I saw some cases that the new implementations impact the normal user, which doesn't use the feature. That is not, allowable. And another thing is about feature gating. You know that we have user-provided feature gate, which you can enable, disable upon the start of the component. And also I want to mention that internally, we can also have this kind of mechanics. For example, instead of putting the checking feature gate everywhere across your implementation, what you can do is that put your implementation as a pluggable unit. And upon the registering of your pluggable unit, just check the feature gate once. If it's enabled, plug in them, and if it's not, just leave it as is. This can save a lot of checking logic individually across your code base when you implement a feature. And when you implement the feature, another thing to think about is that which mod you want to get implemented. Whether you want to do it solo yourself, or you want to manage it and encourage all the volunteers to join in. So if you want to cooperate with others, make sure you all have a comprehensive understanding on the PR dependencies. For example, of course, API PR should come first, and then the others. So know the dependencies, and as a first contact of the KEP, you should implement all the PRs which stands in the critical path, so that you can make the rest of the things in parallel and then catch the deadline of the release. And also another thing is that don't stop there to waiting for a PR to merge and then go to next. You shouldn't do the development in batch. Instead, do it in parallel. So how to do that? Here, the pattern I used is I call it a streamlined pattern. So for example, we have 3 PRs. We need to implement 3 PRs, and they have the dependency one by one. And the thing I did is that after I finish PR1, which contains commits A and B, I just right away go to implement the PR2. I don't wait for the reviewers to finish the review of PR1. Then, so in PR2, I just branch off that based on PR1 and make the additional commits, as well as PR3, et cetera, et cetera. So that once PR1 gets merged, what I need to do is just rebase PR2. Then the PR2 will only display the delta commit that is really belongs to PR2, which in this case, the commit C. So, yeah. But the good thing is the developer process is under control by you, and you usually can catch the deadline. But the cons is that you have to do a lot of git rebase. So don't be frustrated by the super amount of git rebase. Well, until now, I can't find a better solution on this, because if you want to leverage the CI, you want to make a fast development pace, maybe this is the only way you can do. All right. Okay, next is about test. So usually in Kubernetes, we have different kinds of tests. The first one is unit test. It's focused on very individual unit of functions. Usually the test that sits in the same package of the source code. So because we are implementing new features, so there's a must that each PR must come up with proper test. And I just list some tips here. So my habit is that before git pushing, I just run local tests to ensure all the tests are passed. Otherwise, I don't want to spend time or spend resource on the test infrastructure on the stupid failing code. And also, Golang provides some facility like detecting the racing condition, like -- race. But usually, run the detection once it's not necessary to catch the race. So you can also use the -- count to run it multiple times. And also, you should follow the Golang table-driven test convention. I will mention that later. And also, you can disable caching if you want. Otherwise, the unchanged test will not run in the next Go test. And also, here's another topic. It's about flakes. Yeah, flakes is very tricky to debug. So make sure you can ensure your code is healthy in the very beginning. So there are some cases that can cause flakes. For example, you have a variable defined in several places. It's a shared usage in different tests. For example, you set a feature gate, but without setting it back. And also, maybe in the last test, there's a Go routine not finished yet, because tests are finished, but the Go routine inside that test may not finish. If that Go routine is still there and holds some shared variables, and the next maybe will have a chance to read the wrong data, sort of. And also beware for Go routine leaks. If the Go routine inside your test function is waiting for some channel, stop channel, make sure that stop channel is closed properly. Yeah. Another thing I like unit test is that sometimes unit tests can help you to detect some smelly code. If you cannot write good or elegant unit tests, sometimes it's a signal saying that this code needs refactoring. So consider about refactoring them, for example, using interface to replace struct, or sort of. And last tip is using mocking stuff. It's especially useful in the unit test. For example, if your code logic is using a struct of clock, that, for example, in the real logic is that it has to wait 5 seconds and then check if it's healthy. If it's a real clock, in the unit test, you have to follow the 5 seconds interval, then see if your unit test works. But if the clock is an interface, then in your unit test, you can use a fake clock. Says that 500 milliseconds represents 5 seconds. Then that can make your test faster and controllable. Yeah. This is about unit test. Here is a quote by Dave Cheney about some opinions on unit test. And the next thing is that unit tests focus on the correctness of the functionalities. But sometimes we have multiple options for the implementation. What can I do? How can I tell which one is better? A good way is using the benchmark testing framework provided native by Golang. And so here is an example. We changed the internal data structure in the EvenPodsSpread, and it turns out the performance is pretty good. So that we have the numbers, so it gives us a lot of confidence. So writing a benchmark test is not that hard. So you can transfer a unit test to a benchmark test like here. So in unit test, what you do is using testing.t, but in benchmark, using testing.b. And also, you don't need to check the return result because you focus on the performance, not the correctness. And also, before starting the benchmark, you must reset the timer because those preparation steps, the time spent on those steps shouldn't be counted. Okay, this is for benchmark test. The next thing is for integration test. I will be very quick. So integration test in Kubernetes is built to test either different sub-component for your feature. In this case, for example, in the scheduler, we have different phases like predicates, preemption, priority. So it can test the individual sub-component as well as can test the combination of different sub-components. Also, it can test high-level component interaction. For example, I give an example, 10-base eviction here. It's amazing test that combines all 4 major parts of of Kubernetes. For example, it has to test node lifecycle manager, and also test the scheduler, and also admission, because admission is part of the API server and apply some extra fields to the object. And also, because integration test doesn't come up with kubelet, right? And if you want to really simulate a kubelet, maybe you have to run some Go routines to report habit back to the API server to make sure the node object is really ready. Otherwise, it's just a fake API resource there, the node API resource. All right. So fundamentally, integration test is actually a unit test because but with some external dependencies, like integration usually starts the API server as well as the etcd. Okay, here's some code from Bill Kennedy. He says that integration test is testing 2 or more units of code, and in Go is testing through multiple packages. Next is end-to-end test. End-to-end test, if you look at the picture here, it sits in the top, which means it will run slow and also cost more because the cluster spin up needs money. And one point I just want to highlight here is that you should not put all your test cases in the end-to-end test. You just need to cover very basic happy and negative paths of your function. The other parts should be covered more in either integration test or unit test because end-to-end test runs slow and also cost money. Yeah. All right, so test, enjoying writing test. It's mandatory for you to get a KEP implemented. And the tests are the only testers because at the alpha phase, you don't have external users testing that for you. And actually, it will pay back. It will pay back because sometimes if you're refactoring the code has been changed, but the test is still there. So still maybe live longer than the original version of your implementation. So treat it seriously. And okay, I forgot to mention ad hoc or called manual tests. So personally, I'm a little aggressive. I didn't use the manual test to test my feature. But if you want, you can use some mechanism like using count. If you don't know count is a way to quickly spin up a local cluster based on your source code. And also, I'm using another way to DIY a way to start a multi-node cluster, but it only works for control plane kubelets. It's inspired by the kube-mark implementation. It's using the hollow nodes. So it's a little fancy, but you can check it out. All right, we are almost run out of time. I'll mention it very quickly. So next step is to make sure you know all the code review guidelines. So don't make very low-level mistakes. And because the PR is for the users to read, for the reviewers to read, make sure you make them document well, and don't just put PR without any description, and separate the commits in reasonable units. Oh, last thing is to chase the reviewer in a reasonable pace, but don't push too much. And next thing is the documents. So basically, there are two kinds of documents. One is inline documents, which stays in the source code, in the API source code, usually in the types.go or some other places. The other one is to, you have to submit a PR to Kubernetes/website, then it will be published to the Kubernetes.io. Okay, last section. Some tools I used, I cannot live without. The first one is the AG. It's a super fast text searching tool. For example, if you want to search in the current implementation of benchmark test, you just AG testing.b. Then it will list out all the current examples you can check out. So it's multiple times faster than grep or any other tools. The other tool is use Git to view all the changes. This is good because you can very quickly go to some commit and enter and see what's the files here. For example, yeah, it has a lot of files, right? You just enter someone, then it will directly jump to that position. And GRV is another tool for Git management. And also there are some Git commands I really like. One is the git checkout dash, which can you to check out to the last user branch, and also some other. I won't mention them one by one. The last thing is that half a year ago, I transferred from VS Code to Golang because I have to switch the branch very frequently, as not only in the feature developing as well as the code reviewing. But VS Code doesn't give very fast reflection because it doesn't have built-in index, but Golang does have. So I transfer for that for efficiency. So basically, this is today's session. So I will go somewhere if you have questions. Yeah, thank you.